This training video was provided for the Central Energy Plant with Navy Federal Credit Union located on 4810 West 9 Mile Road, provided by Pugh and Associates.
The orientation for this is just to get you used to or recognize what we've put in so that you can understand or know the equipment that we're using.
I'll let him tell us
Okay,
what
we
the
have
system
three
is.
different systems in this building. One's a dry, it feeds the generator room. Then you got the pre-action, is the MDF room. And then you got a dry, wet system that covers the offices and all the generators. They're simple valves, they're easier to set up, and a lot easier than it used to. You used to have to take the face off, pull water in, and put the face back on. You don't have to do that. This is all external. Just turn it off, clapper sets itself, pump it over there, and turn the water on. It's really a simple system, the easiest system to work on. That's about all you got. You got just three systems in this building. And you got an inspector's test at the far end of the generator room, the drain, that dry. You got one down here in the chill water room. And then this ADF room, you got one right around the corner above the ceiling. That's just to get any kind of excess water that you have, get it out. And on this ADF room, it's a double interlocking system. You have to have two smoke detectors go off and a loss of air before that thing will kick on. We have simulated it 2 or 3 times. Everybody seems to be satisfied with it, so we flowed the wet, we tripped the dry. It's not nothing we don't normally do every day. So we got 2 fire pumps in the pump room. They're up there in series. One comes on, and if it can't keep up, the other one will come on. This supplies all of Building 5, Building 6, and Commons, and also the new construction up here with the 2 6-stories. So,
Phase 2.
Phase 2, yeah.
And there's no secondary pump to the buildings, it's
No,
just
just
pump
the
from
two.
here only to the
Exactly.
buildings.
Anyway, that's what it is. We got two jockey pumps, 2 fire pumps. Jockey pumps has been online for 3 or 4 weeks now. Fire pumps will go online today. So, anything we got going after today, we have to make sure that we all on the same page.
Okay, when you guys running the pumps, that sequential start that he referred to, I don't know if you picked up on that or not, but the sequential start, what happens is if the first fire pump comes on, I don't know what it is, but let's say it's 1,000 GPM pump. So they're down the line and it's a major fire, parking deck, a whole half a level type thing, so you're needing 1,500, 2,000 gallons of water. Well, the sequential start, what that pump will do after a period timer, when it's not getting enough, then that timer kicks on and it turns the other pump on, so then you've got twice the flow going in that direction, whichever direction it might be. We'll cover that in the pump room.
Yeah, we'll cover that. Is there any questions on the actual sprinkler systems and the?
Can we test those pumps separately, or, you know, like you say they're sequential, we can put, on test day, we can test them.
So that's what we do here. We run one pump, and then we run the second.
Well, understand, a sequential start means that as long as a pressure's being satisfied, the other pump's not going to interact anyway.
Yeah, that's why I asked.
So
Run
yeah.
the other one manually.
Yeah, one is the primary pump and the other one's the slave pump. So the primary pump's going to do what it can do until it can't, and then the secondary pump kicks on. So they want to be tested in any way you want to do it. So, well, y'all want to move into the
Yes,
pump
sir.
room so we can take a look and see what we
On
got.
that note, I guess.
This is the wet system. Like I said, it covers the chill water room and the offices. And it's just a basic flow switch and a drain. That's all it is. Flow water, get it on, and then when you turn the water off, fill the system back up at the place whatever's wrong, reset the panel, and set right back up. And then this is your dry.
That covers all the office.
All the office and the chill water area, big warehouse area. This one right here covers all the generator room. This is one where you got all those 6 big generators. This is the dry valve that operates that. And basically the same thing, when you have a fire, drain it down, replace the heads or heads, and set it back up. When I say set it up, you got a knob back here that you compress, turn clockwise, you'll hear the clapper go click. That means it's set up. And all you do is have to open the valve, start rolling water with this valve open. And then gradually close this valve, and it'll set itself up. This is your pre-action, one that feeds the ADF or MDF. This one right here is, when it trips, it'll basically drain itself. Because it won't trip unless this solenoid tells it to trip. The panel's got to tell the solenoid to trip. When it trips, it's just boom, that's it. It'll fill the water, fill the pipe with water. And that's coming off the smoke detector. The smoke detector extinguishes smoke, takes two. One will go off, and then when the smoke gets thicker, the second one will go off. That will activate the solenoid, that will activate water in the pipe. But the water will not come out of the pipe until you have a head burst.
The control valves located in the riser room at the central energy plant are butterfly valves, and they have a built-in tamper switch that will be sent to the alarm panel when closed. This is the wet, the dry, the pre-action. All have main drains, which are tagged main drain on every one of them. And you open this in case of to get the pressure off the pipes and stuff. You just want to open that, which these go into a 2-inch pipe that is connected to every which one. The main drains for the dry is right here, the wet's located right there, and then for the pre-action it's right here as well. All go into a 2-inch pipe that goes out the north end of the wall, and we'll show you that that location here in a minute. The air compressor is a gas air compressor. It feeds both the pre-action and the dry valve. Both have low air supervisory switches that will send an alarm to the panel if the air gets low.
Okay, the fire pumps are horizontal split case, just like the ones, I guess the other, I think you've got two different sets of pumps. We spoke of the vertical, and then these are horizontal split case as well. They put relief valves on these, and I don't know if you have them on your other one or not, but this kind of speaks to what you were referring to about the size of the pump. What they did is they took 1,000 GPM pumps, but they added 112 pounds of head pressure to static pressure. So out here you've got 60, 70 pounds of pressure. You got 112 pounds of lift onto that, so you essentially got over 175 pounds of head pressure. When you design a system and you have that type of pressure, you've got to have a relief valve to relieve that pressure off. One of the design differences, and I don't know what that pump up there has. Typically, when we see one set up with a flow meter like this, the water, once it comes out of the pump head and goes into the major piping, if there's not a fire and you're wanting to do a test, you've isolated the system, and then that water is recirculating back in. But the design engineer did this one so that it dumps to the outside. So when you actually do a live flow, whoever's doing your inspections, they'll want to do a flow, and they're going to get their 1,000 GPMs, and they're going to get 1,500 GPMs, or try to see if it'll produce that much without pulling down the static head. One of them is the primary pump, so then the other one's on sequential start. So this is the pump that's going to come on and generally run first on demand. What's going to happen is this one's going to try to keep up with whatever the event may be. If it can't, then the other pump will cut in to deliver the additional water pressure that's needed to fight the fire, whatever the case is.
Here at the CUP, we have 2 fire pumps. We have one feed. It's going to come into backflow preventer, double check, and it's going to go on over here, come down. This is to the suction side of pump 1, and it'll continue. Follow me over there to that T, and it'll come in, and it'll go to your backup fire pump into the suction size here. You have your discharge for the pump, which will come around and will connect here to one feed that goes and feeds building 5, 6, parking garage, and the tower. We do have a bypass. That's where this T would be. In case these fire pumps were to fail, the bypass, which is the T, goes up and into and connects to the piping as well. It has a check valve, 2 butterflies, and that is just, like I said, that's to make sure you have water in case fire pumps do go down. You have relief valves that are attached and will be piped outside, and we'll show you where that goes as well. And test headers on both of them that come up, connect, and go around, and they come out the north wall as well. And let's go take a look at those. This was the test header for both pumps. Again, they're connected in there, and we just talked about this is your relief valve piping, and this is your main drain that earlier we talked about all the risers connecting to, and that's all that's on the north wall of the CEP. Testing the flow switch for the wet pipe sprinkler system, need to open the valve located in the chiller plant labeled inspector's test, which discharges out of the north wall of the CEP. The draw pipe valve is equipped with an alarm pressure switch. For testing, the inspector test is located in the generator room and is discharged on the east side of the wall.
How should we test these things if we test them? Because I know like up at building one, up at the parking deck, parking deck one, if that if that pressure is not 155 or higher before we start our test, the pumps turn on wide open. Boom, I mean, hit hard, come on wide open. Because with these variable speeds, testing is a little different. And when we do test it, should we test it to where it triggers the relief valve and let the water flow, or should we just test it and let it churn?
Well, quite honestly, if you have a fire, it's not going to wait for that perfect circumstance, whatever it may or may not be. My recommendation is, and always is, you will walk into the room, and if the pressures are normal to a degree, something weird hasn't happened, and you guys know these systems from looking at them day in and day out, hit like you do on the other systems, open up the pressure relief off the side of the controller, put that thing in action and let it do what it's going to do. Because that's the real work.
Okay, well, what it is, when it comes on wide open, sometimes we got like some dry systems, we've had it overpower the valve for the generator system over there because air pressure may be down just a little bit or something. That pump kicks on like that, boom! It trips that dry system and fills that generator room.
Okay, well, what identifies that to you that?
Well, what we see over there is on our pressure gauge on the controller, if it is not above 155, we start that pump, it starts ramping up. If it's below 150, it comes on hard, wide open. If it's between 150 and 155, it comes on and starts ramping up till it makes 155, then it'll start backing off. And for testing, it's kind of difficult. What we've been doing is turning the jockey pump on, making it 155 or better, testing, it comes on at a low speed and just sits there and runs at a low speed for 10 minutes. And then we shut it off.
Okay, well, there's two different ways to address it. One is having identified that's what the issue is. You can take and reprogram the computers and the controllers. Number one, you can take the jockey pump and you can increase that pressure so that at any given time, that jockey pump is going to put out 155 or 160 pounds of pressure, period. That's always. So because you shouldn't have to have that problem. Every time you walk into a room, you should be able to just walk over something. Okay. That's it. If it's has little caveats to everything you want to do. Can you imagine if you didn't know the building, you know, my God, you'd walk in there and destroy the whole place and not know it. Right. So it needs to be addressed through programming. Okay. So we raise the values of, if this is cutting off at 150, 152 or whatever, well, as time bleeds over, it may not come on to 125. So you're going to see that 125 to 151 or whatever it is spread. So it's not bad that you can identify that when you walk into the room because nobody knows these pumps better than you guys do because you see them all the time. And that's kind of where you need to be with this one is just like the others. You need to know what its little caveats are. Right. But presumably you'll be able to take and put this one up to where you can have that guaranteed pressure. And you can, depending on whatever that window is. And then if we increase the pressures on this one, then we increase the pressures on that one. And I say increase pressures, we're speaking of on and off pressures only. It has nothing to do with generated pressure. Now, these are variable speed. I didn't even look, so I wasn't aware that these are variable speed controllers. that's a whole different animal than the conventional fire pump that you guys have in the other ones, I presume. I know the Horace Flint case
Right.
is not, it's a conventional
Yeah, it's very
pump. Are the ones in the parking deck, are they variable speed?
Yeah.
Okay, well, so you guys
They
got.
got the same cabinet and everything, just like these right here.
Okay, well, they,
Except for
The secondary.
the secondary pump.
Primary is very.
Primary has this big one just like I'm right here.
So as long as pressure's on a normal, like we were talking earlier, we won't need to run a jockey pump to build that pressure up to then test the pump.
well, you shouldn't have to.
Okay.
But again, it's like,
You have to learn.
this is y'all's building.
Right.
So I can sit here and tell you all kinds of good little things, but the truth is, you're the ones that got to deal with the consequences.
Okay.
If you walk in there, there's no point in creating a problem and you know the solution. All I got to do is push the button for a minute and I'm ready to go. And I don't create a problem. So in knowing that, the simple answer is probably that. The fire, if you have a fire and that pump comes on and it does something, well, okay, that's a different issue. I'm not going to cause it as a cause and effect type thing. So, I'm not going to start trouble that I can't finish.
Right.
But, so either way, I mean, you do have options. So.
This concludes the training video for the Central Energy Plant, Navy Federal Credit Union. Should you have any questions, please contact Pugh and Associates, 1-850-478-2777.